Hi there, this is Jacob Nash, and in this video, we'll be talking about indeterminate forms. As a side note, there are only two more videos that I'll be making for this section of Calculus 2, and they're going to be pretty brief, just because they also include things that we've already done, um, but I'll try to provide as much explanation as you might need. Okay, so indeterminate forms. So you might be like, oh, great, back to limits. Well, don't worry, it's not going to be terrible, if you didn't like limits from Calculus 1. But first, we just need to think like, don't you remember how in Calculus 1, sometimes you got some of these, probably mostly these, and you just might not know what to do with that. Um, these are five different what are called indeterminate forms that we just don't, I mean, this could result in multiple values, so the limit will not tell us anything useful. So these are the five that you need to know. 0 over 0 is 1. Infinity over infinity. 0 to the power of 0. Infinity minus infinity. And 1 to infinity. All five of these are just not able to be calculated mathematically. Um, so that's why they're indeterminate forms. Here's one over here that people oftentimes think is an indeterminate form, but it actually isn't. If you ever got infinity to the infinity, it is not indeterminate, it's actually infinity. Now, it can make sense if you think about the graph x to the x. So if you have the function x to the power of x, and you take the limit of that as x approaches infinity, if you plug in infinity, this is what you would get, right? Infinity to infinity. But the graph x to the x, it would only make sense that you would think that's going to go to infinity. Like think about it. 1 to the 1, 2 to the 2, 3 to the 3, 4 to the 4, that gets super big, and of course it goes to infinity. So that's why this one's not indeterminate. Um, Now, just because you get these as answers when you do limits in calculus 1, we probably just stopped right there. But this time we can use something called L'Hopital's rule. Um, it's something that's like, okay, too bad, we actually can solve this. And you might have learned about it before, depending on if you took AP calculus or something, but maybe not. Um, but regardless, I'm going to explain what it is. It may also be referred to as L'Hospital's rule, but technically L'Hopital's is the right thing to say. Although technically that L'Hôpital means hospital in English from French, but it's not named after a word, it's named after a person. So, anyways, uh, so L'Hôpital's rule is simply this. Sorry that this is glitchy image. Um, this was screenshotted from uh, someone with the initials FK. Not sure who it is, but thank you for providing this notes on 345edu.yup. So anyways, using L'Hopital's rule, we can say, all right, we're not able to do f of x divided by g of x. How about we take the derivative of both? And if you do that, you might be able to do the answer. Sometimes you have to do L'Hopital's multiple times. You're like, L'Hopital, L'Hopital, have to do it multiple times. Now, careful, only use L'Hopital's rule if you can and if you need. Both of those statements aren't actually the same. So what do I mean by if you can? You only can if the limit of f of x and g of x on their own exist. If either of those are, let's say, infinity, can't do L'Hopital's rule. Um, now, also, if you need, you could technically use L'Hopital's rule on any limit that you want, but you'll actually sometimes, not always, though, you will sometimes get the incorrect answer if you use L'Hopital's when you didn't need to. And how do you know if you need to? It's if when you try to do the limit, you get one of these. So I hope that didn't seem confusing, but basically just only use this if you need to and if you can. Here's an example of where you need to and can. First, let's think about can we? Or actually, we should probably think about do we need to first. So let's plug in 1, ln of 1, 0. 1 minus 1, 0. Right here, 0 over 0. That might tell us we need to use L'Hopital's rule. Can we, though? We can, because the limit of uh, both the numerator and denominator equals 0, and 0 does exist. So you can use L'Hopital's rule. And what I always write is lol, like L apostrophe HO, to say I'm using L'Hopital's rule here by the equal sign. And I say take the derivative of both those freaking things, and we get 1 over x and x if we take the derivative of both those. And then you plug in 1. Now we get 1. Yay, we did get an answer. So if you chose your answer as 0 over 0, that's incorrect because if you do L'Hopital's rule, you actually find out that the limit equals 1. And if you happen to plug in this function in the Desmos, you could see that that's actually what happens as we approach 1. So that is it for this video. That was pretty brief. Obviously, examples can get way more complicated than just this, but just remember, if you get any of these five, you might need to use L'Hopital's rule.